Hello dear students, welcome back to SL Classes, my YouTube channel. Today our topic of discussion is kinematics from our first year syllabus, that is chapters motion in straight line and motion in plane. And today we are on the way to discuss some advanced level of questions from this chapter. We were already discussed some basic level of questions in lecture 1 in the previous video. Okay. So if you are new to this YouTube channel, I request you to watch and practice the basic level of questions which is already uploaded. And today we are going to discuss some advanced level of questions from this chapter kinematics. Okay. So I will show you the question on the screen first, then I will give you the detailed answer. Okay, so let us start with our first question. Please listen. First question. Between the two stations, a train accelerates uniformly at first, then moves with a constant velocity and finally retards uniformly. If the ratio of the time taken be 1:8:1 and the maximum speed attained be 60 km per hour, then what is the average speed over the whole journey? And options are given: 48 km per hour, 52 km per hour, 54 km per hour and 56 km per hour. Okay, so in the first question, it is given the motion of a train between two stations. And to describe its motion, we have to use the velocity time graph of its motion. It is given that initially the train uniformly accelerates. We know acceleration or positive acceleration means velocity of that body increases. And after some time, the body moves with constant velocity. That means its acceleration will be zero or velocity is uniform. And again after some time, the body retards. So, in the velocity time graph, it is seen very clearly. This is the velocity time graph. In the first part, the body accelerates, which means its velocity increases. See clearly. Then it moves with the uniform velocity, that is velocity is constant. After that, velocity decreases, that means it has a deceleration. And the ratio of time, it is given 1:8:1. If we take this time as t, this is t, then this time should be 8t and the final time again t, or t:8t:p. Okay. And the maximum velocity it can attain, that means in the first part, its velocity increases due to acceleration and it reaches a maximum velocity. That value is given 60 km per hour. In that maximum velocity, the body moves in the constant velocity region. After that, it decelerates. And we need to find the average speed during the motion. We know what is average speed or average velocity. Speed. Average. We have an equation to find speed average, that is total distance by total time taken. This is the equation to find average speed. So we have to find first the total distance, that is distance in this region. We can take this distance as S1 and this distance in the second region, that is S2, and distance in the third region, that is S3. And from velocity time graph, we know that area of velocity time or area of speed time graph will give distance or displacement. So area in this first part, to find this S1, we have to find this area of this triangular portion, because area will give distance or displacement. So this is a triangular portion. So we have the area half into base into height. Base is taken as t and height is 60. So t into 60. Half into 60 we can cut it and we will get 30t. Okay. What about the second distance S2? This is a rectangular portion, right? So the area of rectangular is length into breadth. So multiply this length and breadth. This will be 8t and this will be 60. So this is equal to 60 60 into 80t, that is equal to 480p. Okay, now what about the third distance S3? Again find the area. This is also a triangular region. Again half into base is this value. This base is again t and height is 60. So t into 60 will get 30t. Okay, so in this equation, what is speed average? That is equal to total distance, that is S1 plus S2 plus S3. That is 30t plus 480t plus 30t divided by total time, that is t plus 8t plus t. Okay, so what is this value? 30 plus 30, 60, 60 plus 40, 480, that is totally 540t by t plus 8t plus t, that is 10t. We can cancel this t. 540 by 10, so answer will be 54 km/h. Okay, so that is a concept question. If you know the equation for average speed and what is the idea we have to get from this velocity time graph, then you can easily find the answer for this question. Hope you can understand. Then we are moving to the next question. Please listen. Next question. Two cars A and B are moving with the same speed of 45 km/h along same direction. If a third car C coming from the opposite direction with a speed of 36 km/h meets the two cars in an interval of 5 minutes, the distance of separation of two cars A and B should be. And options are given: 6.75 km, 7.25 km, 5.55 km and 8.35 km. Okay, so this is the situation given in the question. There are two cars A and B moving in the same direction. You can see A moves in this direction with a velocity 45 km/h. The second car B is also moving in the same direction with the same velocity 45 km/h. But the third car C moves in the opposite direction with a speed of 36 km/h. These are the data given, and it is one more data is given, that is this car C meets these cars B and A in an interval of 5 minutes. What does it mean? Which means, see, this car C moves in this way. Okay, so after some time it will reach here. The car C will reach here. Then the car again moves. So after crossing the car B, the car again moves in this direction, and after some time the car C meets car A, and the time interval between the meeting of B and A is 5 minutes. This is the data given. That is, the car C meets B and A. First the car meets B, and after some time the same car meets A. There is a time interval of 5 minutes in this process. So the question is, what is the distance of separation? That is the separation between A and B. What is the distance between them? This is the question. Okay, this is again a concept based on relative motion. And one more thing you have to notice, that after crossing the car B, the car C takes 5 minutes to reach car A. So we have to take after this crossing point. So after crossing B, after crossing B, what is the relative velocity between C and A? See, here these two cars are moving in this opposite direction. So the relative velocity of C with respect to A, that is equal to 36 plus 45. 36 plus 45, because when two bodies are moving in the opposite direction, we know that the relative velocity will be velocity of one body plus the velocity of the other body if bodies are moving in the opposite direction. So 36 plus 45. will be 81 kilometer per hour. That is the relative velocity. So what is the distance covered? We have S equal to V into T. From the equation V equal to S by T, we can write S equal to V into T. That is equal to velocity is 81 in kilometer per hour into T. That is 5 minutes or 5 by 60 hour. After calculation, we will get, see, this value was in minute, time is given in minute. We can convert this minute into hour because this value is in kilometer per hour. So 81 is in kilometer per hour. So we have to convert this time into hour because 5 minutes is given. So 5 by 60, that is in hour. And after calculation, you will get this value as 6.75 kilometer. So for the given question, the correct answer will be 6.75. That is option 1. Okay. Now we will discuss our next question. Please listen. Next question. A stone dropped from a building of height h and it reaches after t seconds on earth. From the same building, if two stones are thrown, one upwards and other downwards, with the same velocity u, and they reach the earth surface after t1 and t2 seconds respectively, then options are given: t equal to t1 minus t2, t equal to t1 plus t2 by 2, t equal to root of t1 t2, and t equal to t1 square into t2 square. Yes, that question is somewhat difficult question. You please listen very carefully. Motion of 3 stones are given in the question. Okay, in this picture you can see here, this is the first case. This is a building or this is some height h. First stone is dropped. This is the dropped body and its initial velocity will be 0. If a body is dropped, you know, its initial velocity will be 0. And that stone reaches the ground in t second. Okay, after some time, t second, it reaches the ground. Then, 2 more stones are projected. One is thrown upwards from this height with the velocity u. So, the body moves upwards for the first time interval. Then after some time, due to gravity, that body will move back to the ground and reaches the ground in t1 second. That body is thrown upward and reaches a maximum height, then returns back to ground. One more body, the third body. What happens to the third body? The third body is thrown downwards. Not dropped, thrown. So it has an initial velocity u. The same velocity u, and the body again reaches the ground in t2 second. And it is asked to find the relation between t1 and t2. How these 3 time intervals are connected. So to solve this problem, we have to write some equations by considering these 3 bodies in different situations. Okay, so for the first body, we can write this body is dropped, maybe this height is taken as h. So for the first body, we can write s equal to ut plus half at square. This is an equation, you know that. And for s, the displacement is h is equal to, for the first body initial velocity is 0, so 0 into t. Okay, we can omit that term. Then half a, that is acceleration due to gravity g, and t is given t only, so h equal to half gt square. Let it be there. Then for the second body, what about the second body? We have to write the same equation s for the second body. But listen very carefully, the body moves first in upward direction, then moves back in the opposite direction and finally reaches here. In that situation, when you write this equation, we generally take this displacement as minus h. What is displacement? Displacement is the shortest distance between initial point and final point. See, this is the initial point, this is the final point. So this shortest distance will be the displacement, but the body moves in the opposite direction, so we have to take the displacement as minus h. So minus h equal to, again it has an initial velocity u and its time is t1, so we write u t1 minus the body first moves in the upward direction. So when the body moves in the upward direction, we take the acceleration as negative. So minus half g t1 square. Or we can write this is minus 8. We can multiply with a negative in the left side and right side. So we can write h equal to, this is minus u t1 plus half g t1 square. That is the equation for the second body. Okay, let it be there. Now consider the third body, body number 3. That body is thrown downward. So we can write again the equation is equal to ut plus half at square. Only downward motion, so the total displacement is h only. From this point to this point, displacement is h. Equal to u, the velocity is u and the time is given t2. So u t2 plus half g t2 square. Thus, we got 3 equations for h. For the dropped body, h equal to half gt square. For the body thrown up, h equal to minus ut1 plus half gt1 square. And for the third body which is thrown down, h equal to ut2 plus half gt2 square. We can take this as equation number 1. This may be equation number 2. And this is taken as equation number 3. Okay. From equation 2 and equation 3, the left side is h and h. And for this h, we can substitute half gt square. So what is this equation becomes? So h half gt square equal to minus ut1 plus half gt1 square. Okay. In other words, we can take this half gt1 square to this side. Here already half gt square. Take this half g as a common term. So half g into t square minus t1 square, right? When this plus half g t1 square comes in the next side, into the left hand side, this half g t1 square becomes minus half g t1 square. So take this half g outside, half g into t square minus t1 square. Okay, that is equal to, here remaining term is minus u t1. So this may be equation number 4. Keep it there. In the same way, here again h equal to ut2 plus half gt2 square. Instead of h, we can substitute half gt square. So this becomes half gt square equal to ut2 plus half gt2 square. Here again take this half gt2 square to this side and take this half g as a common term. So half g into, here remaining is t square. Then take this term to this side, you will get minus t2 square, that is equal to u t2. This is equation number 5. Now divide equation number 4 and equation number 5. 4 divided by 5 gives. What do you get? When we divide this term, this left hand side half g and this left hand side half g, after dividing this will get cancelled. So what remains here? T square minus t1 square. T square minus t1 square by what remains here? T square minus t2 square. T square minus t2 square is equal to. Then the right side of equation 4, that is minus ut1. Right side of equation 5, that is ut2. When divide 4 and 5, when we divide 4 and 5, we can again cancel this u. What remains? Minus t1 by t2. So minus t1 by t2. Okay. Now you cross multiply these two. Okay. You will get t2 into t square minus t1 square is equal to minus t1 into t square minus t2 square. Remove the brackets. Remove t outside. And finally you will get t is equal to root of t1 into t2. This will be the answer solution for this question. This question is little bit difficult one, so you write this question 2 or 3 times and practice. Okay, hope you will understand. Then we are moving to our next question. Okay. Next question. The trajectory of a projectile in a vertical plane is y equal to ax minus bx square, where a and b are constants and x and y respectively horizontal and vertical distances of the projectile from the point of projection. The maximum height attained by the particle and the angle of projection from the horizontal are, and different options are given. One is b square by 2a comma tan inverse b. Next is a square by b comma tan inverse 2a. Next is a square by 4b comma tan inverse a. And the other option is 2a square by b comma tan inverse a. Okay, that question is from our projectile motion. And an equation is given, y is equal to ax minus bx square. In that chapter, we have studied trajectory of a projectile. There is an equation to find trajectory. First of all, you have to by heart that equation. That equation will be like this: y is equal to x tan theta minus gx square by 2u square cos square theta. That's the general equation for y in terms of x. That is called the equation for trajectory. So in the given equation, it is given that y is equal to ax minus bx square. We can compare these two equations. What is the meaning of this equation actually? What is this y? What is this x? Theta is the angle of projection. This y and x, we know when we take a projectile, a normal projectile, an oblique projectile, projected from here, okay, with an initial velocity u and an angle theta, okay, a body is projected. Then after some time the projectile reaches here. That means the projectile has this much horizontal displacement and this much vertical displacement. This is called x, this is called y. After some more time, body maybe reaches here. X varies, y also varies. So the trajectory equation actually gives what is the vertical displacement after covering a horizontal displacement x. See, if this is x, this will be y. If this is x, okay, if this is x, this will be y. So the value of y, that is the value of vertical displacement in terms of horizontal displacement, that is the idea, or that is the need for this equation of trajectory when solving a question. Okay, so you first understand that the meaning of trajectory of a projectile. This gives the vertical value after covering a horizontal displacement. The value of vertical displacement after covering a horizontal displacement. So when the motion is completed, we know the horizontal displacement is called the range. Correct? When the motion is completed. And when the motion is completed, x becomes range and y becomes 0. Correct? Because body starts from here and finally reaches this point. When comparing this initial point and final point, the vertical displacement will be 0. When comparing this first point and last point. Okay, if this is the ground level point, this is again the ground level point. So comparing these 2 points, vertical displacement is 0. So when y equal to 0, we can say x equal to r, right? When the vertical displacement becomes 0, the horizontal displacement becomes range. Substitute in this equation. Therefore, 0 is equal to ar minus br square. When y equal to 0, x equal to r. Instead of x, we have to substitute r. So take this minus br square to this side. So br square is equal to ar. Cancel one r. You will get r is equal to a by b. Okay, that's the value of range. Now we have to find the maximum height reached by the projectile. What is the maximum height? Maximum height means y is equal to h max. When y becomes h max? When y becomes h max? When x equal to r by 2. Correct? This is totally range. This is half of range. So when x equal to r by 2, here y equal to h max. So in the same equation again, so this is equation number 1. So again 1 becomes, I can write when y equal to h max, x equal to r by 2. So again substitute here y, instead of y you can write h max equal to a into for x you have to write r by 2. What is r? R is a by b. So a by 2b, we have to write r by 2. R is a by b. Therefore r by 2 is a by 2b. So a by 2b minus bx square minus b into x square, where x is r by 2. Okay, where r by 2 is a by 2b. So x square becomes a by 2b the square, right? X square is a by 2b the whole square. X is r by 2, where r by 2 is a by 2b. So calculate this one. A square by 2b minus a square b by 4b square, right? 2 square becomes 4, b square is b. We can cancel one b here. So a square by 2b minus a square by 4b. So this is a square by 2b can be taken outside. So a square by 2b into 1 minus 1 by 2. 1 minus 1 by 2 is 1 by 2. So a square by 2b into 1 by 2 becomes a square by 4b. So this is the answer. H max is a square by 4b. That is one part of the question. What is H max? And also it is asked to find the angle of projection. When comparing these two, here x tan theta, here ax. So here the coefficient of x is tan theta, here coefficient of x is a. So comparing these two terms, we can write tan theta is equal to a. Therefore, theta is equal to tan inverse of a. This is the answer. So H max and the angle of projection can be calculated in this method. So this is again somewhat difficult question. You have to practice thoroughly, then only you can understand the solution. Okay, fine. Now we are moving to the next question. Please listen. Next question is: a projectile is fired from the surface of the earth with a velocity of 5 meters per second and angle theta with the horizontal. Another projectile fired from another planet with a velocity of 3 meters per second at the same angle follows a trajectory which is identical with the trajectory of the projectile fired from the earth. The value of acceleration due to gravity on the planet is given g equal to 9.8 meters per second square. And options are given: 16.3, 110.8, 3.5 and 5.9. Okay, how can we solve this question? Two projectiles are given. One is projected from Earth and the other is projected from another planet, and some data are given. In the first projectile, that is projected from Earth, its initial velocity is 5 meters per second. The angle is given theta, and we know for Earth g equal to 9.8. And for the other planet, that velocity of projection is 3 meters per second, and the angle is same. That is the angle which you used to project in the Earth. Here again the angle is the same value theta. We have to ask to find the value of g on that planet. And one more data is given. Both the projectiles have identical trajectory. This is the key idea to solve this problem. Identical trajectory means they have equal range or equal height. Okay, both are same. So we can take range 1 is equal to range 2. For the projectile projected in Earth and the projectile projected in planet, both have identical trajectory. That means both have equal range. What is the equation for range? We know that u square sine 2 theta by g. That is again equal to u square sine 2 theta by g. Here we have to write U of Earth, here U of planet. Here G of Earth, here G of planet, and sine theta or sine 2 theta, theta are same, so we can cancel this sine 2 theta. Now substitute values. For Earth, this value U is 5 or 5 square by G Earth is 9.8. That is equal to here U planet is given 3 square by G planet. So what is G planet? G planet is equal to, just cross multiply this value, we will get 3 square by 5 square into 9.8. After calculating this, you will get 3.5 meter per second square. Okay, that is the solution for that question. So we wind up this session here. This is the first lecture of kinematics for the advanced level questions. We will do some more lectures from the same topic, that is from the kinematics, okay, by including some other different type of questions, okay, how you can understand this video. You just write your comments and feedbacks in the comment box, okay. Also you just demand your needs. I will upload videos accordingly, okay. Bye for now. We can meet again.